This is going to be a fairly introductory level talk about layout tests, specifically as they're used in Chromium, although most of it applies elsewhere as well. There are a lot of subtopics here that I could spend the whole time talking about, but I won't. So, what is a layout test? Well, you've heard a little bit about them from Darren already. It's a set of about 10,000, 11,000 tests that Chromium uses that have been imported. We got them from WebKit. They got them from a bunch of different places, a whole chunk of them from W3C and such, and wrote a whole lot themselves as well. We've also written a number. Fundamentally, they are web pages. They're HTML files often, but not always. They use JavaScript as well. They typically load up in file URLs, although there's a couple hundred or so, I guess, that use a local web server instead. They have to run over HTTP for various reasons. For Chromium, they run in an executable we call the test shell. For WebKit, they run in dump render tree. We're trying to converge those two, as Darren already mentioned, so that we can use a version of dump render tree for Chromium as well and avoid having to re-implement a lot of the things as they get added to dump render tree. The reason that they use test shell or dump render tree is that these applications have some additional JavaScript objects and methods made available to facilitate the testing. So you can see here the layout test controller has been added to the window, which provides methods such as dump as text, which in this case means that when this test gets run, what it produces as its output to be compared to see whether the test has run successfully is just the text on the page. In this situation, it just says the bit of text and then the pass result. And so the system that runs all these tests takes a look at this test, sees that it needs to compare only the text, and then compares this text that was output with an expected result. Another word for the expected results that you'll see coming up a lot is a baseline. So when people talk about rebaselining, they mean generating new expected results to match reality. So in Chromium, at least, any test that has this dump as text will produce a text output. If it doesn't have dump as text, it will produce a screenshot, along with a checksum of that screenshot that makes it easier to compare, quicker than actually comparing one pixel file to another. If a test produces a screenshot, it's called a pixel test. In Chromium, at least, pixel tests are run by default. You can turn them off with an option to the script. In WebKit, last I knew at least, they weren't running pixel tests by default, but there's an option that can cause them to be run. If you have a test that is producing a screenshot, then instead of the text on the page, since that's not typically useful in many of these cases, it will produce what they call a render tree, which is just a text representation of what the application thinks it's putting up on the screen. Now, comparing two render trees to see if they're the same is a pretty good indication of whether the test has passed, but comparing the screenshots themselves is better for things like repainting issues particularly. It's one thing to say that the application thinks it's putting up a green line or a green to white gradient, another thing to see that it actually really did paint that. So the render tree looks like this. You don't really need to know the details of it, but one important issue is that the sizes of various objects show up in the render tree. Particularly things like sizes of fonts, sizes of form controls, even the size of the entire page once you take into account scroll bars and so on, which means that the render trees tend to be platform specific. The screenshots, of course, are platform specific as well, especially because of stuff like fonts. So there are separate expected results for each platform when you're looking at pixel tests and render trees. Often the text tests, the ones that might just say pass or fail, can be shared among different platforms, but the pixel tests need to be specific to a platform. Although sub-platforms can share them. For instance, Windows XP and Windows Vista might have the same images and render trees, or they might not, depending on the details of the situation. So what's a baseline? Well, as I've already mentioned, there's a set of text tests that only produce the text on the page. And in that case, since the baselines are cross-platform, the expected results will typically be in the repository next to the test itself. If it's a pixel test, on the other hand, then the expected results will be in a platform-specific directory. And currently, there's a different set of platform directories for Chromium's results and for WebKit results, although, as has been mentioned, once we get all of the API upstreamed and so on, we're going to be moving our results up into the WebKit repository as well. I'm going to kind of forward declare something a little bit here and indicate that if you're not sure when you're running the when you're running the layout tests, exactly what result it's comparing to, because there's kind of a complicated algorithm for determining which platform result you're going to be using. Then you can run the WebKit tests script with this sources option, and that makes it print out for each test that it runs what exactly it's comparing it to. But that's getting ahead of myself, as I said. And here we are catching up. So suppose you want to run the WebKit tests. WebKit tests and layout tests, it's a synonymous term as far as Chromium is concerned. So there's the script, and incidentally, I'll be pointing to different scripts, different URLs and things. There's a slide at the very end that has links to all of the URLs and descriptions of paths to all of these scripts, so you don't need to try to remember them now, because I'll be posting the slides, and so you'll be able to just click on them or copy them from there. But, so you run this script. It produces a whole lot of output. Those 3 dots up at the top are potentially pages and pages and pages of standard I/O that this thing is spitting out at you, including things like how many tests it found, which tests it's running, whether they passed or failed, what kinds of failures they were, whether the image matched but the text was different or the other way around, all that sort of thing. And then at the end it produces this summary of which tests passed and which ones failed. Incidentally, all of this is a bit under development. Probably even as we speak, the exact formatting of this output is being changed to make it a little clearer, more easily understood, but the general concept is the same anyway. So once you've run these tests, in addition to the output that it actually spits onto your screen, it also saves the expected and actual results for any test that failed, so that you can compare and see where they went wrong. It saves those here. So you can see in this particular run, only tests in the FAST and HTTP subdirectories had failures. And if we dig down into one of those, you can see that for this particular test, get bounding client, it's showing you the actual result, the expected result, and then 2 different forms of diffs between those. This must have been just a text test, because there's no PNG listed here. But if it were a pixel test, there would be an image and a checksum there as well. So, in addition to running the tests locally on your own machine, of course, one of the useful things that you can do is see that the tests are running on the Buildbots. There's a lot of information all about running tests and so on in the Chromium, on dev.chromium.org. dev.chromium.org, there's a good page with lots of information about running the tests. Not quite so much information about the Buildbots, so I'll talk a little more about those. If you go to the Buildbot waterfall page or the console page and you click on this WebKit link, it will show you, it will limit the number of bots that are displayed on the page to only the WebKit Buildbots. There are still quite a few, but there are Buildbots running WebKit, building WebKit and running layout tests for Mac, for Windows, for Linux. There are release versions, there are debug versions. There are, a little confusingly, multiple versions of the debug Buildbots. They're just splitting the tests into alphabetical chunks in order to get it done faster. So you'll be able to see all of those. If you then go to one of them, if you look at a WebKit tests step and look at the standard I/O, that will show you that long page that was encapsulated in those 3 dots when I was showing it earlier. That's the standard I/O that it received when it ran the WebKit script, just like you would do on your own machine. If instead you go over to an archived WebKit tests step and click on the layout test results, it will take you to a download page where you can download a zip file, which is that directory full of the expected and actual results for any of the tests that failed, that, again, I showed when we were running it on the local machine. What else are we doing? So here's where we go to our live demo, since it's up and running. The historical information that was received from the Buildbots running these tests is shown in this very long and information-packed dashboard, which was originally designed to show the flakiness of the tests. So what you have is, up here we have a list of all the different Buildbots, all the different builders, and a list of the result of each test that has failed over the last several hundred failures. So you can see the different colors represent different results. Green is passed, pink is failed. The numbers would be the time that it took. So this test took 7 seconds to run, which is considerably longer than we want most tests to take. There's an awful lot of information here. I could easily talk for an entire half hour about this dashboard, except that I wouldn't. I would leave that to Ojan, whose amazing work it is. But we'll give just a brief overview. It's good to know that the page exists, and if you ever need more information about it, you can just poke around clicking links, or ask me, or ask Ojan, or ask on the Chromium dev mailing list, and someone will be happy to answer it. By default, again, it shows this view, which shows the flakiness of the tests. You can also get it to show the actual results that a given test produced. So let's just pick one. We'll tell it, here's a test. And purportedly this would load, but it's not. Well, I'm not sure what's up with the network, but here's where we go back to our convenient demo. This is what it would be showing if it were loading, which is to say it's got one test up here, and then it shows all of the expected, it shows all of the results that were produced. Here's the expected, here's the, I hate tap to click, have I mentioned that? The test itself, the Macintosh platform result, the Windows platform result, the images. So this tells you everything all about the test that has failed and why it might have been doing so. So one thing to see on this page, or equivalently on this one, is this column of expected results, the expectations. Where do those come from? Well, they come from, no, I can't get it to go to the next one. All right.
Yeah, I think you just shut down the recording.
Did I?
Yeah. Cool deal.
Okay.
Just minimize that.
Sorry about that. All right. Test expectations. Layout tests fail. We have about 10,000 tests that we're running, of which we know that 500 of them are going to be failing. They fail for different reasons. Some of them we expect to fail all the time because we don't ever plan to implement that feature. Some of them are just slow. Some of them we plan to implement the feature, but it's not up yet, so we don't want to run the test. There's all kinds of reasons that these things might fail. But while they're in the middle of failing, we don't want them to be turning our Buildbots red, because then we would miss later regressions. So we have this file, test expectations, that contains a list of all the tests that we know are going to fail and why. So we have some metadata. Each test that we know is going to fail has a line like this one. It has some metadata at the beginning, some annotations. It has the path to the test, and it has the expected results, or possibly a list of expected results, by which I mean pass or fail, that kind of thing. So metadata might be a bug number. In fact, every test has to have a bug number that describes more about why that test is failing. It could be skip, meaning we don't run the test, slow, marking it as slow, won't fix, debug or release if it only happens in one of those modes, and an optional list of platforms that the test fails on. The expectations might be crash or timeout, image or text saying that it mismatches on the expected image or the expected text, image and text if both. There's also a fail annotation, which is deprecated at this point. Fail used to mean it fails something, either the image or the text or both. Now we've decided to refine that more. So you'll still see fail in quite a lot of the lines, but we'd rather not add it now. Why do we need a pass expectation? Well, a lot of our tests, unfortunately, are flaky, meaning sometimes they pass, sometimes they fail. And we wanted to be able to record that as well, so that if that changed, we would know it. Here are just a couple of examples. You can see that there's a test here that it's got a bug number and a small comment about why it's a problem, and then we see that it fails both the image and the text tests. We don't support WebGL yet, so this entire WebGL directory is also marked as not only a failure, but we skip it. There's no point in running tests that we know we're not going to pass. And then for this third example, you can see that on Windows, only in debug mode, we sometimes pass, we sometimes fail. So we've recorded that just so that we know what's going on. So suppose you want to fix a layout test. It's a good thing to do. It's a good way to get started working with the Chromium code. You can look through this list of test expectations for a failure that looks like you might know something about it, or that looks like it's pretty tractable. Many of them have revision numbers listed by them to say this came in with a WebKit revision somewhere between these two numbers. So you can see that it's a recent regression perhaps and know somewhere to get a good handle on it. So how would you go about debugging a test? Well, again, this is one of those topics that I could easily talk for the whole time about. So I'll just give a few tips instead, and you can go back to those web pages that are linked at the end and get a lot more information. But a few specific tips for these. There's no real magic to debugging a layout test because they're just web pages. In fact, in most cases, they're relatively reduced test cases. But one of the things you do want to do is make sure that it's not also failing upstream. Sometimes there'll be a test that's just broken in WebKit. In that case, of course, you're still welcome to fix it. It would be a great thing to do, but you want to look at the WebKit source code to fix it and fix it there rather than trying to see what's broken in Chromium. You can see if the test only needs rebaselining. A lot of tests, it might be that we're actually getting the correct result, or at least a correct result. Some of them differ, say, in the exact text that V8 might produce in an error message. And the error is still the same, but they've chosen a slightly different wording, in which case our result is generally just fine, and all we need to do is produce a new baseline, a new expected result. You can take a look at that flakyness dashboard, see how long the test has been failing, whether this is only since the last WebKit merge or only in the last few revisions. It'll give you an idea of when to get started looking for a regression. If none of that tells you much, then you're left just debugging it the same way you debug any sort of compatibility problem. Load it up in the test shell, either interactively in a debugger or non-interactively if it doesn't fail that way. You might need to run it along with some other tests that are nearby. A lot of the tests, perhaps it's not the failing test that's actually causing the problem, but the one that ran right before it has left some garbage behind. The test shell does not quit and restart between every layout test because that slows it down too much. So there may be some garbage being left behind that you need to clean up instead. If that still doesn't show you your problem, then you might need to take a look at the Buildbot environment. If you look at the top portion of the standard I/O for one of those Buildbot outputs, it'll show you all about the environment variables, the fonts, everything that Buildbot thinks it knows. And if your system doesn't quite match that, then maybe that explains why you're not seeing the failure when the Buildbot is. There's a lot more details about this, as I said, on the webpage on devchromium.org. So I mentioned that one of the things you might need to do when you're rebaselining a test, when you're trying to debug a test, is in fact only rebaseline it. Usually that's cause for celebration because rebaselining a test is a whole lot easier than actually finding a problem. There are two main ways that you can go about rebaselining a test. One of them is pretty automatic. There's this script called rebaseline that lives with the other WebKit layout test scripts, in Chromium, I should say. And to use that, you just add rebaseline to the test expectations file in your own local copy. Don't check that in that way. Then you run the rebaseline script, and what it will do is go out to all of the Buildbots, find the most recent run for each platform, copy that data into your own local repository, patch up the test expectations file correspondingly, and then let you create a change list and review it and have it committed in the usual way. So you don't need to have a Mac or Linux machine or Windows. You don't need to have all three of those anyway. You do need to have one. But if you don't have all of the platforms available to you, you can still rebaseline the test on all of them all at once. Alternatively, if you do have the platform available, you can just run the WebKit tests script there with the new baseline option, along with the name of the test that you want to rebaseline. And then when it produces the actual results, it'll just copy them into your local repository, paving over what might already be there. And again, you can create the change list, have it reviewed, check it in the usual sort of way. Sometimes we have cases where we want to write a new layout test. Often this will be something where we find a bug in Chromium that wasn't caught by any of the existing layout tests. There's also a number of new layout tests that we have in our local repository in the Chromium tree that need to be adjusted and sent upstream. So this is a similar situation. Again, there's a lot of information online about how to do this, but I'll touch on a few key points. First is that when you're writing a new layout test, keep in mind that you're writing it for WebKit. What you're writing is a WebKit layout test, and you're going to be submitting it into their tree. So you use their guidelines, their style. You'll be using a Mac to generate your first set of results. But given that, it's true that tests that have never failed in Safari are still good tests to have. They're still entirely welcome in the WebKit tree. So something that Chromium encountered that didn't fail any of the existing layout tests, by all means, write a new layout test for it and send it in. Even if Safari doesn't fail it now and never has, they might sometime in the future, so it's a good way to catch regressions. And of course, any new embedder that decides to come along and embed WebKit will have more tests to make sure that they're doing it right. You can look at existing tests for examples to see how to write these things, but be careful not to look at ones that are too old. It would be good to go into the WebKit repository and find one that's been modified at least, if not newly written, within the last few months, because their conventions have changed. They've got new frameworks and new ways of going about writing these things, so it's good to look at a new one. Then you just file your bug at bugs.webkit.org, wait for review, make a patch, eventually get it committed into the tree, then it eventually comes back down with the next WebKit merge into our tree. And you may need to create new baselines for that. So warn the WebKit gardener so that they can be aware that we'll have these failing layout tests until you make the new baselines that then come into our tree. And that's pretty much it. So here's that list of links and locations that I'm sure is really hard to read, but the goal is for you to be able to click on them, not memorize them anyway. And if there are any questions, I'd be happy to answer them. We still have the microphones up here. Okay, I guess we're done then. Bring the next person up to mess up the recording.